Hello everyone. So today we are going to start the example based on this retaining wall. So today we are going to solve the example based on this retaining wall. Okay. So let's start. So the first example, that is the masonry retaining wall of trapezoidal section, that is 6 meter high, 3 meter wide at top and 2 meter wide at the bottom. The wall section trapezoidal section ની છે 6 મીટર હાઇટ છે એની 3 મીટર ટોપ વિડ્થ છે 2 મીટર બોટમ વિડ્થ છે. ધ અર્થ સાઇડનું જે પણ ફેસ છે એ આપણને વર્ટિકલ કીધેલું છે. ધ સોઇલ ઇઝ લેવલ વિથ ધ ટોપ ઓફ ધ વોલ. So we have to find out the maximum and minimum pressure intensity at the base of the wall. સોઇલનું યુનિટ વેટ આપણને આપેલું છે 16 kilonewton per meter cube, and the angle of repose, that is the phi, that is given to us 30 degree. Masonry weight, that is given to us as a 22.5 kilonewton. So first let note down the whatever the data that is given to us. Okay, so here these are the data that given to us. So these are the data given to us. Here the top width is given to us as a 2 meter, the bottom width, that is 3 meter, height of solid HS. So here they have mentioned that the soil level will with the top of the wall, so the soil will be retained up to the top of the wall. So the height of solid as well as height of wall will be the same as 6 meter. Okay, density of solid, that is given to us 16 kilonewton per meter cube, and rho d, that is the density of the material of the wall, that is given to us 22.5 kilonewton per meter cube. Here this term is new for you, that is the phi, that is angle of repose. Generally you have studied this term in the strength of the material subject, so we have to use it over here. Okay, so here let's depict all this data in the form of figure. So in the figure, the top width is given to us as a 2 meter, the bottom width, that is given to us as a 3 meter, the height of soil as well as height of the wall. So here in this case the soil will retain up to this height, up to this. Okay, the soil will be retained. So and wall is also up to that level. So the height of solid as well as height of wall, that is both will be the same as 6 meter. Okay, so whatever we have done in the dam, same thing we have to do in this retaining wall also. First we have to compute the forces that acting over this retaining wall. So the first we are finding out the earth pressure. So earth pressure will be acting, so just I will draw this representative figure of this earth pressure over here. Okay, so the earth pressure will be acting and its distribution will be look like this triangular one. So whatever the base intensity, it will be a Ka gamma into H, and this height is H. Okay, so first we need to compute this value of Ka. So Ka will be what? That will be 1 minus sin phi divided by 1 plus sin phi. So phi, that you have to put the 30 degree, you can easily get the value of Ka. So it will 1 minus sine 30 degree divided by 1 plus sine 30 degree. Sine 30 1 by 2 થશે. So 1 minus 1 by 2, that is 1 by 2, and 1 plus 1 by 2, that is 3 by 2. So your K will be come out as a 1 by 3, or we can say 0.33. Okay guys, so how to find out this K value that we have seen? We can directly put this equation of K in the equation of total pressure also, but it is generally preferred that compute the things stepwise, then it will be the easy to solve this example. So step by step we have to compute. We have computed this value K that come as 1.33. So here we can write this Ka. That will be equal to 1 by 3. Okay, so gamma, that is the density of soil, that is 16, that we know, and height, that is the height of wall, that is none to us 6 meter. So just we have to put the total pressure. So total pressure will be area of this diagram. So area will be 1 by 2, base will be a Ka into gamma into h, gamma will be a 16, h will be a 6, and height, that is h, again 6. So just you have to do this. Okay, so here in this, here it is 16 into 6 square divided by 2 into this portion, that is Ke. So by using this calculation you can get the pressure, soil pressure, as a 96 kilo Newton. Okay guys, then we have to second compute the weight. Okay, so weight will be what? That will be nothing but the, let's first we'll remove this. How to compute this weight? So weight will be nothing but it will be the area multiplied by the density. So here what is area? Area will be the area of trapezoidal, that is a plus b by 2 into h, and the density given to us as a 22.5, and area we can easily compute from top width and bottom width. Top width plus bottom width divided by 2 into height. So we can get the value of this weight of this retaining wall from this equation. It will be come out as 337.5 kilo Newton. So major two forces that acting on this retaining wall that we have computed. Now we have to compute the CG of this trapezoidal section. For that purpose we know the equation to find out the CG of this trapezoidal section, and by putting this data we will get CG as a 1.27 meter. Now next step that already we have done, same that we have to do. We have to find out the Z, that is equation is given, only unknown with us, that is x bar, that we have find out. So by putting this value we can easily get the value of this Z. Now we know the value of Z. So now we have to compute E, that will be equal to what? So that will be equal to Z minus B by 2. So here Z will be none to us, that is 1.744 minus B, that is 3 meter divided by 2, that is 1.5. So we'll get some positive value, and that come out as a 0.224 meter. So now we have to compute the only two stresses, that is sigma maximum stress and sigma minimum stress, that is W by B 1 plus 6C by B, and the sigma minimum, that is the W by B 1 minus 6C by B. By putting the data in that equation we'll get the answer. Now what is W? That is let's see. So W, that here we have computed W as 337.5 kilonewton. So here we have to put the W as 337.5 kilonewton. B, that is the base width, here we have seen in the starting, that the base width B, bottom width, that is 3 meter. Now next, that is 1 plus 6e eccentricity that we have found as 0.224 meter, and base width B, that is the 3 meter that we have found out. By putting this all data, we can compute the sigma max, and sigma max is coming out as 167.4 kilonewton per meter square. Same way we have to compute the sigma minimum, and it will be come out as 57.6 kilonewton per meter square. Now the main thing is what? How to represent it. Okay, that is the important thing, how to represent it. So here in the case of this retaining wall, this side is known as a toe, and in this side is known as a hill. So the maximum stress is acting over this and minimum stress is acting over this. So we can easily represent it like this. So it is the distribution diagram. It is necessary to draw this diagram. It is the important thing to draw. Okay, so it is important for you guys to draw this diagram. Okay, so here we have completed this example. Now let's take another one example based on this retaining wall, that is a masonry retaining wall, 6 meter height, 0.75 meter width at top and 2 meter width at the bottom. The wall is retaining soil up to the top. The face of wall on soil side is vertical. The lateral pressure due to the soil that varies from 0 at the top to the 3.2 kilonewton per meter square at the bottom. A specific weight of masonry, that is 24 kilonewton per meter cube. We have to draw the stress distribution diagram due to the self weight of wall alone and due to the self weight of wall and the soil pressure. So here in this case, the pressure is already given to you. You have to draw the diagram only due to the self weight and self weight plus earth pressure. So let's see here the data given, that is the top width, that is 0.75 meter, bottom width, that is 2 meter, and height of solid as well as height of wall, that is both will be the same in this case also, that is the 6 meter. Okay, the density of the wall material, that is the 24, and the pressure at base. Okay, so here they have directly given the pressure intensity like this. The pressure intensity what we have found in last example, that is directly given to us as a 0 at top and 3.2 at bottom. So it is directly given, no need to compute this, it is directly given in this example. So we have to use directly this intensity and compute the total stress. So here the intensity, here directly we have put the intensity 3.2 and compute the total force that we have computed PS. Okay, that is coming out as 9.6 kilonewton. So the total force that is coming out as 9.6 kilonewton. Okay, next we will find out the weight. So weight will be equal to nothing but the area into density. So it is area and this is density. So the area of trapezoidal section easily we can find out. Top width 0.75, bottom width 2, height is 6, density is 24. So just put all the data and find out this weight. So we have find out the weight, we have find out the soil pressure. Now next what we have to compute? We have to compute the CG of that trapezoidal section. So we can easily compute the CG from the equation. We have to do the lot of practice to find out this CG. So we can easily find this CG. Okay, x bar. So from this x bar we can easily compute this z from the equation of z that we have derived previously. So we can easily find this z value, that is coming as 0.8309. Now what we have to compute? We have to compute the eccentricity, that is z minus b by 2. Okay, z coming as 0.83, and what is b? That is known to us, that is 2 meter bottom width. So 2 by 2, that is 1. So it will becomes a negative. So here the eccentricity come out as a negative. What does it indicate? So eccentricity is coming as a negative. So what does it indicate? It indicates the maximum stress on the vertical face. So now we have to compute the maximum and minimum pressure. So we can compute this maximum as well as minimum pressure. So we have to compute this maximum pressure from these equations. Just we have to put the data. So now what is W over here? So W that we have find out here over here, that is 198 kilonewton that we have to put over here. Okay, B that is bottom width that we have find out in the start of this example, that is 2 meter bottom width. So W by B, okay, 1 plus 6E by B, E that we have find out as 0.1691. Now we have to put the E eccentricity without sign in the equations that we have already note down in the DEM, that eccentricity just you have to put without keep in mind the sign convention. So you have to put the eccentricity, you will get the maximum stress as 149.23 kilonewton per meter square. Now same way we have to compute the minimum stress. Okay, so we can get this minimum stress as 48.70